October 2025, mid-morning, East Coast time. Millions of people try to access their work tools. Slack, Atlassian, Snapchat, PagerDuty, Zendesk. None of them works. Not because those companies went down, because Amazon Web Services, the cloud provider that hosts huge portions of the internet, had a catastrophic failure in one region, Northern Virginia. But because critical global services depended on that one region, the failure spread worldwide. For 15 hours, major platforms were either completely down or severely degraded. This is the story of what happens when the infrastructure that powers the internet fails. Why the cloud is just other people's distant computers, and what it really means when a handful of companies control the digital infrastructure modern life depends on. Welcome to The Breakdown Economy. I'm Tony, and today we're talking about Amazon Web Services, the cloud provider so dominant that when one of their regions fails, huge portions of the internet fail with it. AWS controls about 31% of the global cloud market. That's more than Microsoft Azure and Google Cloud combined. Yes, combined. Netflix, Airbnb, LinkedIn, NASA, the CIA, thousands of startups, millions of websites. If you've used the internet today, you've almost certainly used AWS without knowing it. And that concentration creates a problem. When AWS fails, large portions of the internet go down with it. AWS operates in regions around the world. Each region contains multiple availability zones, essentially separate data centers designed to be independent. The idea? If one availability zone fails, traffic shifts to another. Redundancy, resilience, no single point of failure. And for most failures, that works. A hardware problem in one zone? Traffic routes around it. A network issue? Other zones handle the load. But there's a problem with this architecture. Some AWS services are regional. They operate independently in each region. But other services are global. They depend on specific regions to coordinate across the world. Guess which region most of those global services depend on? US-EAST-1. Northern Virginia, the oldest and largest AWS region. I have personally designed multiple enterprise networks in this region. It's not just a region, it's the region, the one where AWS launched, the one where many core services operate, the one that global services use as their coordination point. I am the service that manages who can access what across all of AWS, coordinates through US-EAST-1, DynamoDB global tables, databases that sync across regions, coordinate through US-EAST-1, Route 53, DNS that routes traffic globally, heavily dependent on US-EAST-1. So, here's the nightmare scenario. What happens when US-EAST-1, the region that global services depend on, has a major failure? By October 2025, AWS had become critical infrastructure, not just for tech companies, for businesses, governments, healthcare systems, and financial institutions. Slack, how millions of teams communicate. Atlassian, project management for enterprises worldwide. Snapchat, a social platform with hundreds of millions of users. PagerDuty, incident response for IT teams, all built on AWS, all depending on AWS staying online. And most of them had made a critical architectural decision. They put their primary infrastructure in US-EAST-1. Why? Because it's the biggest region, with the most services, the lowest latency to major East Coast cities. It is the obvious choice, which meant when US-EAST-1 failed, they all failed together. October 2025. Around 10 a.m. Eastern Time, a Tuesday morning, businesses are in full operation. Teams are communicating on Slack, developers are using Atlassian, operations teams are monitoring systems through PagerDuty, everything is normal. And then DynamoDB, AWS's managed database service, starts experiencing problems in US-EAST-1. At first, it's subtle. Some database requests are slower than usual. A few transactions are failing. Nothing catastrophic. But within 30 minutes, the problems cascade. DynamoDB isn't just a database service people use directly, it's infrastructure for infrastructure. IAM, AWS's identity and access management, uses DynamoDB to track permissions. When DynamoDB starts failing, IAM can't reliably determine who's allowed to do what. And when IAM fails, nothing else can authenticate properly. The cascade accelerates. 10:30 a.m., DynamoDB severely degraded. 10:45 a.m., IAM authentication failing. 11 a.m., customers can't access AWS console. 11:15 a.m., services in other regions start failing. 11:30 a.m., complete operational failure for US-EAST-1. And here's where the regional failure becomes global. Remember those global services that coordinate through US-EAST-1? DynamoDB Global Tables, IAM for Worldwide Access Control. Route 53 DNS. When US-EAST-1 fails, those services can't coordinate properly anywhere. So suddenly services running in perfectly healthy regions, Europe, Asia, South America, start experiencing authentication failures, database sync problems, and DNS issues. A regional problem just became a global crisis. The impact was immediate and widespread. Slack. Millions of teams suddenly can't communicate. Messages are not sending, channels unreachable. Entire companies go silent. Atlassian, Jira, Confluence. Project management and documentation systems are down. Development teams can't track work. Support teams can't access tickets. Snapchat, a social platform with hundreds of millions of users, unable to send snaps, view stories, or access the app. PagerDuty, and here's the cruel irony, is an incident management tool. It's what IT teams use when things break. During the AWS outage, PagerDuty went down because PagerDuty runs on AWS. So, IT teams experiencing the AWS outage couldn't use their incident management system to manage the AWS outage. The tools you need when infrastructure fails were unavailable because the infrastructure failed. AWS's status page started updating around 11 a.m., an hour into serious problems. We are investigating increased error rates for DynamoDB in the US-EAST-1 region. Then, we are working to restore full functionality. But hour after hour, no resolution. The status page kept saying investigating and working on restoration. Noon. Still down. 1 RPM. Still down. 3 RPM. Still down. 5 RPM. Still down. For customers whose entire business ran on AWS, each hour felt like an eternity. What actually broke? AWS's post-mortem was vague. They described it as issues with DynamoDB control plane that affected multiple downstream services, configuration problems, cascading failures, complex interdependencies. But here's what they didn't clearly explain. What was the root cause? Why did it take 15 hours to fix? What exactly failed? The lack of detailed explanation concerned a lot of technical people. When a cloud provider that hosts critical infrastructure has a 15-hour outage, complex interdependencies isn't a satisfying answer. It suggests they either don't fully understand what went wrong, or they understand and don't want to share the details. Neither is reassuring. The outage stretched through the entire workday. Morning meetings missed. Afternoon deadlines blown. End-of-day reports impossible. Around 7 p.m., 9 hours after the initial problems, partial recovery began. Some services started coming back. DynamoDB showed improvement. IAM began authenticating, but full restoration didn't happen until after midnight. Over 15 hours total for some services. 15 hours. More than half a day. An entire business day was completely lost for companies that depended on AWS. And because this was US-EAST-1, the region everyone uses, it affected a huge portion of AWS customers. The impact of a 15-hour AWS outage was staggering. This wasn't just annoying. This was business-critical infrastructure failing for over half a day. Let's start with the immediate business disruption. Slack went down for 15+ hours. Think about what that means for remote-first companies. 20 million daily active users. Millions of companies use Slack as their primary communication tool. For a full business day, they had no internal communication. Teams scattered across time zones couldn't coordinate. Decisions stalled. Work stopped. Some companies had backup communication, email, phone, Microsoft Teams, but many had become so dependent on Slack that when it disappeared, they were paralyzed. And here's what makes it worse. This wasn't Slack's fault. Slack's application code was fine. Their engineers were ready to work. But Slack runs on AWS. When AWS fails, Slack fails, even though Slack did nothing wrong. Atlassian's suite, Jira, Confluence, Bitbucket, went down for enterprise customers. Software development teams couldn't access bug trackers. Product managers couldn't update roadmaps. Support teams couldn't resolve customer tickets. For companies in the middle of critical releases or handling major incidents, the Atlassian outage was catastrophic. You can't manage an incident without access to your incident management tools. Snapchat's outage affected hundreds of millions of users. For over 15 hours, people couldn't send snaps, view stories, or access the platform. And for influencers and businesses that use Snapchat for marketing, a full day of lost reach. Campaigns interrupted, audiences unreachable. Revenue was lost not because Snapchat made a mistake, but because their cloud provider failed. Then there's the operational nightmare for IT teams. When AWS is down, you can't access the AWS console to investigate, read logs to diagnose problems, deploy fixes or updates, scale services up or down. Basically, do anything to help you just wait. And the teams that built their entire infrastructure on AWS, they were completely helpless. No failover to other providers because migrating to multi-cloud is expensive and complex. No manual intervention because everything is in AWS, and AWS is inaccessible. Just waiting for Amazon to fix it. AWS's communication during the outage was minimal. Regular updates saying, "We're working on it." But little detail about what broke, why it was taking so long, or when it would be fixed. For enterprise customers paying AWS hundreds of thousands or millions of dollars per year, that level of communication wasn't acceptable. AWS has service-level agreements promising 99.99% uptime for most services. That's about 52 minutes of downtime allowed per year. A 15-hour outage blows through almost 2 decades of allowed downtime in a single day. AWS will issue credits to affected customers, but credits don't compensate for lost revenue, destroyed customer trust, or the realization that your entire business depends on infrastructure you can't control. After the outage, there was the predictable wave of "you should have multi-cloud" commentary. And technically, that's correct. If you distribute your infrastructure across multiple cloud providers, a failure in one doesn't take down everything. But multi-cloud is expensive. You need to maintain infrastructure in multiple clouds. Learn multiple platforms' peculiarities. Build abstraction layers to work across them. Pay for redundant resources. And test failover constantly. For most companies, that's not economically feasible. So they accept the concentration risk and hope AWS stays online. October 2025 showed what happens when that hope fails. All right, let's break down what AWS's October outage teaches us about cloud infrastructure and dependency. Lesson 1. Regional failures can have global consequences. The failure was in US-EAST-1, just one region out of dozens worldwide. But because global services depend on US-EAST-1 for coordination, the failure propagated globally. This is a critical architectural decision that AWS made. Centralize certain global services rather than making them truly distributed. It's more efficient to coordinate through one region, simpler to maintain, easier to ensure consistency. But it creates a single point of failure for worldwide operations. When that one region goes down, services in healthy regions can't function properly because they can't coordinate. Lesson 2. The cloud is just someone else's computer. We talk about the cloud like it's this magical, distributed, resilient thing. But the cloud is just data centers, servers, databases, network equipment, all physical infrastructure that can fail. And when you move your infrastructure to the cloud, you're not eliminating risk, you're transferring it. On-premises infrastructure, servers in your own data center, you control. When something breaks, you can fix it. You own the risk and the mitigation. Cloud infrastructure, you don't control. When something breaks, you wait for the provider to fix it. You've outsourced the risk and the mitigation. Most of the time, that trade-off makes sense. Cloud providers have better engineers, better redundancy, and better security than most companies can afford. But when they fail, you're helpless. Lesson 3. Infrastructure concentration creates systemic risk. AWS controls 31% of the cloud market. Microsoft Azure adds another 25%. Google Cloud is about 11%. 3 companies control about 2/3 of cloud infrastructure globally. That concentration creates efficiency, economies of scale, better services at lower prices. But it also creates systemic risk. 2025 saw significant outages from all 3 major providers. June, Google Cloud, 7+ hours October, AWS, 15+ hours November, Cloudflare, CDN provider, 2+ hours. Each one took down massive portions of the internet infrastructure. Each one showed how concentrated our digital infrastructure has become. And because most companies can't afford to diversify across multiple clouds, they're stuck accepting the risk that their single provider might fail. Lesson 4. Transparency matters. When infrastructure fails. AWS's post-mortem for the October outage was vague. Complex interdependencies, cascading failures, configuration issues. That's not good enough for critical infrastructure. Compare AWS's vague explanation to Cloudflare's detailed post-mortem from November. Cloudflare explained exactly what broke: a database permissions change, duplicate entries, an oversized feature file, global propagation, and a crash. Specific, technical, detailed. So other engineers can learn from the failure and prevent similar issues. AWS, much less detailed, which makes it harder to trust they fully understand what went wrong or how to prevent it next time. When you're critical infrastructure, transparency isn't optional. People need to understand failures to make informed decisions about depending on you. Here's the uncomfortable reality. Modern digital infrastructure is more concentrated than it's ever been. 20 years ago, companies ran their own servers in their own data centers. Infrastructure was distributed by necessity. Every company had its own. Today, most companies use one of 3 cloud providers. That concentration brings huge benefits: efficiency, scale, sophisticated services that individual companies couldn't build. But it also means that when one of those 3 providers fails, massive portions of the internet fail with it. After the AWS October outage, many companies reevaluated their cloud strategy. Should we multi-cloud? Should we keep some infrastructure on premises? Should we build in more redundancy? And those are good questions to ask. But the answers are often unsatisfying. Multi-cloud? Expensive and complex for most. On-premises backup requires infrastructure expertise that many companies no longer have. More redundancy? More. Costs money that startups don't have. So most companies will continue depending heavily on one cloud provider and accepting the risk that the provider might fail. Has AWS improved since October? Probably. They've likely implemented safeguards for the specific failure mode that occurred. But complex systems fail in new and unexpected ways. The next AWS outage won't be a DynamoDB control plane failure. It'll be something different. Because that's how infrastructure works. You fix one vulnerability and another emerges. The question isn't whether AWS will have another major outage. The question is when and how long it'll last. So what can you actually do about cloud concentration risk? 1. Understand your dependencies. Map what cloud services your business depends on. Know what happens when they fail. 2. Have contingency plans for critical operations. If AWS goes down for 15 hours, can you operate manually? Can you communicate with customers in another way? 3. Don't assume the cloud means reliable. Cloud providers are more reliable than most companies' own infrastructure, but they're not infallible. And 4. Advocate for true multi-cloud capabilities and open standards. The current concentration benefits cloud providers more than it benefits customers. The internet shouldn't depend this heavily on 3 companies, but right now it does. AWS's October 2025 outage lasted 15 hours. For cloud infrastructure at that scale, that's a catastrophic failure. But most of the time, AWS works. Most days, the services are online. Most companies don't experience disruption until they do. And then they're reminded that the cloud is just other people's computers. That's it for this episode of The Breakdown Economy. If this made you think about the infrastructure your digital life depends on and how concentrated it's become, hit that subscribe button. After episode 9, we're wrapping up season 2 with a look back at all 10 major failures we've covered and what they tell us about the breakdown economy. I'm Tony. Know your dependencies, plan for failures, question concentration. And remember, in the breakdown economy, the cloud isn't magic. It's infrastructure. And infrastructure fails.